Hello everyone. Today I will show you how you can set up Trino to analyze your data sets within BigQuery. It's very common that many customers are migrating their Teradata environments to BigQuery, and when they are using nPath, which is a Teradata proprietary function, they may face issues because nPath is not available within BigQuery. The closest match for nPath is match recognize. Unfortunately, today, as of today, we don't have match recognize function within BigQuery, but we have that match recognize function within Trino. And you can use Trino BigQuery connector within dataproc to directly connect to BigQuery and run your queries again BigQuery using BigQuery storage API, which means the queries does not charge slot usage and it's only used by dataproc cluster. So I will show you how you can set up your environment easily and query your data within BigQuery using match recognize function with Trino. First of all, what we have here is a sample data set, which is called Trino demo. Within the Trino demo project, we have sessions data set, and I have some data like clicks data. And they're like session IDs, page ID, requested page ID, timestamp, geolocation, and platform. So anything, any query shown here is actually within Teradata blog post regarding nPath. So we will query these two tables, clicks and clicks to tables, and use match recognize to show the functionality, how nPath functionality can be replaced with match recognize. So how we set up, so basically if you want to run match recognize within BigQuery, you will get error because match recognize is not available here. And you need to create a dataproc cluster. So if you go to dataproc and create a cluster, so you will see here some available components as of today. There is Presto, but Trino is the new release of Presto. So we don't have Presto yet. But I have provided the init action for the Trino, and I hopefully this will be available in the public dataproc repo. I already created the pull request. So yeah, my name is Samet Karadak, by the way. So you can reach out to this repo in my GitHub, github.com, Samet Karadak initialization actions. So here you will see that there is the Trino folder and there is trino.sh, which is the init action. So what you need to do is you need to download this trino.sh and upload to a GCS bucket first of all, because we need to create a dataproc cluster with the init action. So here you see if you create the cluster and you can add initialization action. And this is what we will do in this video. So I don't have any dataproc cluster. Let me first start bucket, class storage bucket. This is a brand new project for the demo. So I will call it Trino init, and it is not available. Trino init actions, and put it EU multiple region standard, continue, create. Okay, I have the Trino init actions. So I already downloaded the trino.sh here. What you need to do is, if you want to create a BigQuery, you need to change this within the connector. So basically, Trino expects you to define a BigQuery properties file, and within this init action, there's a part in 162, line 162, you need to set your project type. So for this purpose, I will give the Trino demo ID here in the init action and save it in the trino.sh and upload this file to Trino init actions. So let me copy this path and all right. Now I have copied this file to the bucket. Let's refresh this. So, okay, we have Trino.sh in the bucket. So what we will do is create a dataproc cluster. I will not use console for this. I will use init action with gcloud command to create a cluster. Trino test is the name. I will use Europe West 4 as the region. I'm using 100 gigabyte disk sizes because we will not store anything on the disk. You don't need to give anything bigger than 100 gigabytes. This will be only a FML cluster with 2 worker nodes. Okay, and the critical thing is we have this initialization action, which we edited recently. So I copied this one and open a command cloud shell and create cluster using this command. Of course, you can use console for creating this cluster with this init action. The critical thing is here, you have this init action. Now it provisions the dataproc cluster. Okay, now our Trino test cluster is created after 3 minutes, almost 3 minutes. What we need to do is get the public IP of the master node here. So if you go to the dataproc VM instance here, Trino test M is the master node. So I need to get the external IP of this. So I copied this external IP and go to your JDBC client. So I'm using data grip here. You can use SquirrelDB if you are looking for a free edition. Within data grip, we have automatically data Trino connector here in the other. So if you are using SquirrelDB, you need to download the JDBC jar file from Trino website and upload this to SquirrelDB and configure your Squirrel client and yeah, connect to the Trino database. So I will give a name, Trino demo here. Host is my external IP and user is test, and let me test the connection. Of course, you need to open firewall to 8080. So I did this already and click OK. Now we have Trino demo. I want all databases here. And within BigQuery, looking at sessions dataset. So I have all the data and tables here. And I'm connecting BigQuery via Trino. So here we have the clicks database, which is exactly this one. So yeah, clicks. All right, so now we have the clicks tables and the connectivity. Let's do some tests using match recognize. So I will open a file here and I will connect to the Trino demo console here. So for example, for nPath, if you go to the Teradata documents here, so let me show you the page here. If you go to the Teradata documentations and in the nPath file, here you see that next page ID. Yeah. So all the examples are coming from this page here. So here in the next example, so if you have this, if you like, you have this Teradata query using nPath, and it asks for next pages. So basically, you got one page, and after that page, what comes next? Basically, this pattern finds those pages. So first page ID and in the next page ID. So we have two symbols, AB variables, pattern is concatenation. So after A comes B. Mode is overlapping, so it continues to search with the next row, so it will get all the next pages here. So this is how you do this on Teradata, which is, if you look for the example, here it is. So this is the star from nPath. So this is the metric recognized equivalent. So as you see, it is almost similar. We are using first page ID. Instead of page ID of A, we use A.page ID. Instead of page ID of B, we use B.page ID. Variables are same. So in the symbols, it's true as A, true as B. We define A as true, B as true. Pattern is here, A.B concatenated. We just need pattern AB. Partition by is the same, and order by TS, it is again the same. So everything is the same. So I will go ahead and hit the, I will first select schema as BigQuery here, and then run. And let me give inline editor. So I choose BigQuery first. I will select sessions and select session. First, I need to give the data set, which is sessions. Right, and run. Now it runs, and we got the results. So here you see for this session ID, the first page ID, next one. So, and you see after 998, so you see the user journey within the web pages. The second example is count rank, again from the Teradata blog post, this one. Here we have the session ID, page ID, and number of counts before coming to that page. So how many pages basically a user traverse before coming to that page. If you want to do this with metric recognize, we have this pattern A star. Within metric recognize, again, we have pattern as A star, A as true. Here we have true as A. Again, count A dot star here. What we have is count star of A. So basically, and we have order by timestamp descending for this pattern. And I will run this one. So this slowness is related to data groups. So if you are using other client, you will see that it will show immediately in a couple of seconds. Okay, we have the count rank of the pages, and you see that this page ID, this session is like they visited 4 pages before coming to this page. And if you are looking for a complicated one, again, we have this. Okay, so this one is the complicated one. So here we are getting multiple counts, and in the define clause, we are looking for if the person goes to first page ID 150 and then 180, or they go to 180 and the category is in some stuff. So we have this pattern within Teradata, and the metric recognized equivalent is we are, since it asks for n of ABC, we can define in metric recognized subset ABC, and we can use any of ABC like this count U dot star. And you have the similar condition. Because in my test data set, I didn't have so much 150 to 180. I created another type of data set, and I have a different type of categories here, but functionality wise is the same query. And I will run this query, which is again a little bit complicated. Example. Okay, yeah, you see these are the results. So yeah, this was it for the match recognize. And let me show how this connector is just responsive. Well, what happens if you create a table here? So let me go to the BigQuery and open a new editor. For example, create table sessions dot clicks demo as let's start from sessions clicks one. All right. So I'm creating a new table within the BigQuery console, which is called clicks demo. Sometimes I need to refresh this page. Okay, I created the clicks demo table here, and let me create the second one, clicks demo 2. And if I go back to the here in the Trino demo and refresh the tree, so I have these tables, clicks demo 2. So it immediately shows within the Trino connector. And yeah, this was it with the Trino match recognize and how you can optimize your cost with the dataproc cluster. So as you see, we are using an init action. We don't need that dataproc cluster up and running all the time. When we need it, we can create the cluster and we can delete the cluster after we finish our analysis to reduce our cost. Or what you can do is like stop start if you don't want to create and delete every time. 2 minutes or 3 minutes is a long time for you to wait for analysis. You can stop start, or if you can, you go to compute engine. What you can do is it can automatically, basically, if you are using just for analysis or ETL window. So if you have an active window working on this one, so you can create a schedule here. So we'll create an instance schedule to, we'll call it stop start, and region is Europe West for Netherlands. Start time. So what you can do is you can use cron expiration here for start, which is cool. Okay, I will start at 8:30, and I will start on Monday, Tuesday, Wednesday, Friday. Yeah, so the weekdays only. So we have our midday, month. So you can use Chrome format, basic. So I will name it Trino Stop Start, and I will use Chrome format. So I can just open this on the weekdays. So if you are not working at the weekend, you don't need to open this. And I will give like, yeah, all the weekdays here. And for stop, I will stop this at, let's say, 5:30 p.m. So I will open it 8:30 a.m. and end date, initiate date is, yeah, I want this to start from tomorrow, and time zone is, let's say, Amsterdam, Netherlands, Central European time. Okay, now we have the instance schedule, and you can add these instances to your schedule. So they will automatically stop and start. This needs to have complete instances start and stop privileges. So if you want to give this, you need to go to IAM admin, IAM, and here add this principal. I think this one, yeah. And I will give compute instance admin here. So it can stop and start the nodes within compute engines. Yeah. Okay, now we have these instances in our schedule, and they will automatically stop and start every weekday, so which will reduce my cost. So I will not be using it like that. This was it. I hope you enjoyed this demo. What you can do is also you can connect. So you can use one client here and add a BigQuery data source as BigQuery, and yeah, BigQuery to, so you can specify your project ID, service account, or user account, and you can connect to BigQuery and Trino within the same interface if you are using a JDBC client like Database. All right, let me know how you find this demo and add your comments below. So yeah, I can update you with the new requests, or if you have any questions, I will be happy to answer those. Thank you so much and have a great day.